Okay, so in order to draw covalent Lewis structure diagrams, we're going to follow a very simple four-step method. So first of all, if you remember from the videos that you watched and the things that you read, covalent compounds are formed from two nonmetals that share electrons to get a stable octet. So you can see my steps here that I have written down. We're going to start with something very simple for our first example. We're going to start with chlorine. Chlorine is what we call a diatomic molecule. It travels around connected in pairs. And so Cl2 is the formula for diatomic chlorine. So our first step that you can see over here is to determine the number of valence electrons available for bonding. So we do that by looking at the different atoms. So I have two chlorine atoms, and each of those two chlorine atoms has 7 valence electrons. I know that because it's in group 17. And so the 7 valence electrons times 2 gives me a total of 14 valence electrons available for bonding. That means all 14 of these have got to be represented in my structure. So that's the first thing we're going to do. The second thing we do is draw a skeleton structure. And what that means is we're going to use the symbols to represent each of the atoms. So I have 2 chlorine atoms. And in this case, we're just going to line them up side by side because we want to keep things symmetrical. As they get a little bit more complex, we'll talk a little bit more about how to figure that out. Okay, the next step, step 3, is to connect the atoms with lines to represent a bond. So I'm going to put a bond in between my 2 chlorine atoms. Each bond represents 2 electrons. So I've represented 2 out of my 14 electrons, which means I have 12 electrons left I have to represent. And then the last step is to fill in the remaining electrons represented by dots until all of the electrons are in the diagram. And if you remember, we're trying to always get a stable octet. And so I want my chlorines each to have 8 valence electrons. And so if each of them is sharing this bond in here, and this bond is 2 electrons, then they each need 6 more electrons. And I do that by putting dots around in pairs, because remember, electrons are in pairs in an orbital. And so I go and put my electrons around each chlorine. So now each chlorine has 6 valence electrons that it's on itself, and then the 2 that they're sharing that makes them bonded in between. So I have 14 electrons represented. If you follow along with me here, I have 2 here, 4, 6, and then there's 2, of course, here in the bond, and 8 for this chlorine, and then I have the same thing over here, 2, 4, 6, and the 2 that are sharing, so that's 8 for each chlorine. And I've represented all 14, right? 2, 4, 6, 8, 10, 12, 14 in my structure. And so I'm done. There's my first Lewis structure. So let's do something that's just a little bit more complex. We're going to do something called water, which you all know is H2O. And so I'm going to start by determining my number of valence electrons. I have 2 hydrogens. Each hydrogen has 1 valence electron because hydrogen is in group 1. I have 1 oxygen. It has 6 valence electrons. I know that because it's in group 16. And so I have 8 valence electrons total that I have to represent in my structure. Now, the next step is to draw my skeleton structure. Now, if it's not just 2 elements, if it's more than 2 elements, you're going to put the single element, thing that appears by itself in the middle, and you're going to put the other stuff around it. So in this case, my oxygen goes in the middle and my hydrogens go around it. And so you want to keep symmetry in mind while you're doing this. Now, the next step is to connect my atoms with bonds. And so I've represented 4 electrons so far, which means if I have to represent 8 total, I have 4 more I need to represent. And so I'm going to fill the remaining electrons represented to the by dots until all the electrons are in the diagram. And remember, again, I'm trying to follow my stable octet rule. I want to get 8 valence electrons. And so I'm going to put 2 here, and I'm going to put 2 here. Now, I've used up all of my electrons, and my oxygen has 8 because I've got the 2 bonds that are sharing 2 each, so that's 4, and then the unshared 2 unshared pairs, which is another 4, so that's 8. But you'll notice my hydrogens don't have 8, they only each have 2 valence electrons. This is perfectly fine because hydrogen is an exception to the octet rule. Hydrogen only ever makes one bond and has no unshared electrons. Hydrogen only ever gets 2 electrons, never any more. So make sure when you're working with any structures, hydrogen only gets 2. And so we're done. We've done our structure for water. Let's try another one. Let's do NH3. NH3 is ammonia. Eventually you'll need to know that when we get to our naming unit, but for now it's okay that you don't. NH3 is ammonia. But we're going to start by determining our valence electrons. And so if I look at this, I know nitrogen has 5 valence electrons, and I'm going to add to that the 3 hydrogens, each has 1 valence electron. So again, I'm going to have 8 valence electrons that have to be represented in my structure. And so I'm going to start by putting the element that appears by itself in the middle, and I'm going to draw my skeleton structure by putting the hydrogens all around it. And then the next thing I'm going to do is combine this and make it a single structure by putting my bonds in. And so I've represented 2, 4, 6. Remember what I said in the last one, hydrogen is okay with its 2 electrons, it doesn't need any more, so I'm going to put these last 2 electrons on my nitrogen. And there it is. I have finished up my Lewis structure for ammonia, and I've represented all 8 of the valence electrons I need. Most things do have 8 valence electrons. Let me get, but there are some exceptions to that. Let's take a look at one more exception, which is BCl3. Let's take a look at this one. If you look at the periodic table, you'll find that boron has 3 valence electrons, and then there are 3 chlorines. Each of them have 7 valence electrons. So I have a total of 24 valence electrons that have to be represented in my image. And so I'm going to start by putting my boron in the middle, and I'm going to bond my chlorines to it, right? And so I have 2, 4, 6 electrons represented so far around my boron. Now my chlorines are going to get the rest of these electrons. Each chlorine needs to have 8 valence electrons, and so I'm going to go through and I'm going to put these on. And the reason why I know they have to go on the chlorine is because boron is another one of those exceptions. Just like hydrogen, it only... Let's do one last example. This one is a little bit tricky. We're going to do carbon dioxide for our last example. And so when I do carbon dioxide, I start by figuring out, just like anything else, my valence electrons. I have 4 from the carbon, 2 times 6 from my oxygen gives me 12, and 4 is 16 valence electrons that I have to represent. And so that's what's got to go in my image. And so I'm going to put my carbon in the middle, and I'm going to put my oxygens around it, because remember what I said about that structure. We want to put the single element in the middle and keep it symmetrical. And then I'm going to bond my carbon to the oxygen, so I've dealt with 2 of my valence electrons on each side there, so a total of 4. So that means I have 12 left. And so I'm going to go and put these around my oxygens. But look what happens. I'm putting these around here, and carbon isn't an exception. Carbon needs to have 8 valence electrons. Carbon needs to have 8 valence electrons. We can't have any weird things going on here. And unfortunately, we're out of electrons. I've represented all 16, but carbon only has 4. So what we're going to do is something kind of different and kind of interesting. We're going to take, these valence electrons here, and we're going to share them with the carbon. And we're going to do the same thing on this side. I'm going to share these valence electrons on this side, which means what I actually have when I move those valence electrons and I shift them, I'm going to erase this a little bit here so that we can see what we're doing. When I shift them around, what ultimately I get, oh, I can't erase those. Let's see if I can get rid of them somehow. Let's pretend they're not there. No, I can't get rid of them. Here, let's just rewrite it because I don't know how else to do that. So once I take these and I move them in here, what's going to happen is my carbon is going to be double bonded to the oxygen on each side. And what I'm left with is only 4 unshared, whoops, can't see it, there we go, 4 unshared electrons on each oxygen. And so now my carbon has a total of 8, it's sharing 4 on each side. And then my oxygen each has 8, 4 that it's sharing, and 2 pairs of unshared electrons. Anytime that you get to the end of a structure, like you did up here, and you don't have enough valence electrons, you're going to have to share extra electrons. So keep that in mind when you're doing your structures. It's important that you pay attention for that. All right, you have a worksheet to work on. Good luck.